Hello, my name is Dr. Suresh Jayaraman and I will be presenting the first video in a series of videos on blind spots in science. A blind spot is a gap in the student's knowledge base that the student is not aware it exists. Uncovering blind spots in the student's knowledge base is the first step towards a good understanding of science subjects and scoring better in standardized tests. To illustrate how blind spots in knowledge stay hidden in plain sight of most students, I will now consider a question most students would think they can easily answer, which is, what does density of a liquid depend on? It is tempting to think that density of a liquid depends on mass and volume. After all, density, mass and volume are related through this equation. But this logic is wrong. Despite the fact that density is related to mass and volume through this equation, density does not depend on mass or volume. How do we know this? The best way, of course, is to do experiments. Experiments with any liquid, say water, show that volume increases in direct proportion to its mass. That is, you double the mass of water, volume doubles too. Hence, density of water, which is given by the ratio of mass to volume, remains unchanged. This conclusion is generally true for other liquids as well. So, what does the density of liquid depend on? Before attempting to answer this question, we will first understand what is density. Density is a measure of how compact a material is. In the example shown, both boxes A and B have the same volume, but box A has more molecules. Molecules in box A can be said to be more compact, or density of molecules in box A is higher than that in box B. This means that to influence density of a liquid, we need to influence the compactness or packing of molecules in a liquid. One way to achieve this is by changing temperature. We know that temperature is a measure of average kinetic energy of molecules. Hence, higher the temperature of the liquid, higher is the average kinetic energy of each molecule, the more it would collide and push away its nearest neighbors, and less compact would be the molecular packing. In other words, density of a liquid will be lower at higher temperatures, a deduction that is borne out by experiments for most liquids except for water between 0 and 4 degrees centigrade. Let us now summarize this video. 1. We learned that density is a measure of how compact a material is. 2. Density of a liquid depends on its temperature. Finally, we saw how a simple equation can conceptually mislead students and create a blind spot in the student's knowledge base. The mere existence of an equation relating density, mass and volume does not imply that density depends on mass or volume. In the next video, I will discuss another blind spot common in most students in grades 10 to 12. This relates to the understanding, or rather misunderstanding, of one of the most celebrated equations in physics, namely Newton's second law of motion. Until then, goodbye and good luck.